Okay, math 30-2, so we're going to do probability assignment number 2 here. I'll post the PDF version of this as well when I post this video. So let's try this out. Let's get my pen in the right mode here. Okay. So a person is shopping for a snowmobile. The probability that he'll buy an Arctic Cat is 39%. Polaris is 27%. And a Skidoo, is 18%. What's the probability the person will buy either an Arctic Cat or a Skidoo? Okay, so because it says or in this situation here, or we're going to do a little addition. Remember, and is a multiplication when it comes to some kind of questions like this. So the probability that you'll do the Arctic Cat or it's more of a union kind of question. The Skidoo, right? I'm just going to add the two probabilities together. And if there was an intersection, I would have to subtract away that intersection as well. But because these look like they're mutually exclusive, there's no intersection between the two. If I do one, I can't do the other. It's just one or the other. They're two different brands. I am just going to add these two numbers together. So it'll be 39 for the Arctic Cat plus the Polaris, 27. And I'm going to get 57. Ooh, that's not right. What did I say here? Oh, I don't know if I said Polaris. Skidoo. I'm going to add those together. I'm going to get 57% chance of that happening. State the probability that a person buys a snowmobile that's not one of these. So if you remember, if I added all these numbers together, so Polaris, or sorry, Arctic Cat, Skidoo, and Polaris, if I added those all together, it'd be the 57 from before. I'm going to add the extra little 27 on there, and I get 84%. So it's 84% chance I'm going to buy one of those three. So what's 100 minus 84? And I'll get 16%. So 16% chance they're not going to buy one of those, they're going to buy something else. So just like the statement I set up here, if it's mutually exclusive, it means that if I do one, I can't do the other as well. They're totally different things from each other. So if I roll here a sum of 9 or rolling a multiple of 4 with a pair of 6, multiples of 4, I just think about what are the multiples of 4. Now, multiples of 4, I'm assuming that like the sums of 4 would be like 4, 8, 12. A 9 is not in there. So 9 would be somewhere in that spot, but they're not. It's not a multiple of 4. So these two are mutually exclusive. Because if I roll a multiple of 4, I'm not going to roll a 9. If I roll a 9, I'm not going to roll a multiple of 4. So they are mutually exclusive to each other. Drawing a jack or drawing a face card from a deck of cards. So these are not mutually exclusive because if I draw a face card, I could draw a jack at the same time because a jack is a face card. I'm just going to write that in there. Since a jack is a face card. It's like if I were to look at the Venn diagram of this thing here, here's my face cards, here's my jack. My jack is inside the face cards, right? Up here, here's my 9, here's the multiples of 4. There's a space here, there's a disjoint between the two sets. Walking to school or taking the bus. If I walk to school, I didn't take the bus. If I took the bus, I didn't walk to school. So they're mutually exclusive to each other. It's not like I can walk and take the bus at the exact same time. Maybe there's a little bit of both if you have to think about semantics there. Drawing a 2 or drawing a spade from a deck. Now, if I look at the Venn diagrams of all the spades and the Venn diagram of all the 2s, there's a 2 in there. There's a 2 of spades. There's a little bit of overlap here. So there's a chance I could draw one or the other. So these are not mutually exclusive to each other. All right, so there's something in here. Okay, so Kai here tosses 3 coins to determine the probability that they land with 2 heads and 1 tail. Now, You can say that like order doesn't matter. So I can toss 3 coins up in the air. If they land with 2 heads and 1 tail, then happen. Just 1 second. Okay, so there's 2 ways to answer this kind of question. What I'm going to do this kind of question is I'm going to think about. All right, so sorry, I was getting a little bit of noise coming out from my door here. One way to do this is just kind of draw a tree. So I got like the first coin, the second coin, the third coin, and then look at the tree and trying to figure out of the tree, which has the 2 heads and 1 tail. So there's not too many outcomes here, but if I had an extra coin, I'd have lots of outcomes here. Each one of the probabilities here, because it's 3 heads and 1 tail, we have to be multiplying here, all the probabilities are a half. So half, 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 et cetera, et cetera. So I'm not going to write them all halves in there. Now, the ones I'm looking for are 2 heads and a tail. So this one here is 2 heads and a tail. This one has 2 heads and a tail as well, right? 1 tail, 2 heads. I think that's it, right? Is that the only ones I have here? I'm looking for 2 heads and a tail. 2 heads and a tail. 2 heads and a tail. So I can't have 2 tails. That'd be bad. We can't have all 3 heads. Okay, so it looks like it's just those 3 ways. Yeah, just those 3 ways. So what you're going to do is you're going to find the probability for all 3 of those, and that's just be a half times a half times a half. And I could do that for all 3 of these. They're all the same. They are mutually exclusive to each other. Doing one is not going to change the other. So half times a half times a half is an eighth. Okay? Yep. So it's 1/8. And then I'm just going to add all of these together here. I'm going to get 3/8. And if I want to put that as a decimal, there's a 37.5% chance that this will happen. 0.375. 37.5%. There you go. Another way to do this is just think, okay, so I got 3 coins. Probability that it's going to be a heads. The probability that's going to be a heads is a half. The probability that it's going to be a tail is a half. So if I multiply these together, I'm going to get 1/8. And then I just have to think about the ways I can rearrange these. I got heads, tails, heads, or I got tails, heads, heads, and they're both 1/8, 1/8. And then I could just add those together. You get 3/8. Okay, there we go. So here we've got 2 mutually exclusive events again. So we got a spinner that has 5 equal parts and a regular dice. One's not going to affect the other. So if I want to do the probability of doing this, it's again, it's an and situation here. Spinning a blue and rolling an even number. What I'm going to do is I'm just going to multiply those 2 pieces together. Okay, so the 5 equal pieces here. So the probability of rolling a blue here is going to be 1/5, or spinning a blue, and getting an even number out of all my dice is going to be a half. See, that's 3 of the numbers are even out of the 6. Right? Then I'm going to multiply those together, and I'm going to get 1/10. So when you multiply fractions, remember you can multiply the tops, you multiply the bottoms, and you get your fraction. Which, if you want to put that as a decimal, or you put that as a percentage, so about 10%. So this one here, you're kind of asking, are they dependent or independent of each other? So like the one above it, they are independent of each other. One doesn't change the probability of the other. If they're dependent, the probability would change. Some key words you're going to be looking for when you're looking at these is like without putting it back, right? So without replacing it. If you put the card back in, like in this one here, that put it back in. Or if the 2 things are just completely separate of each other, like rolling an even dice or an odd number on a pair of dice. Roll in an even number and roll in an odd number on a pair of dice. Yeah. Those are just completely separate. Rolling an even number on one dice is not going to change the second dice because it's two different dice. But because I didn't put the socks back, this is dependent, right? Because I put it back on this next one, it's independent. So that'll change. That won't change my probability. And this one here is dependent. And because we're talking about two separate dice in this last one here, these are dependent. Or independent, sorry. Okay. Liam has 8 identical socks and 6 identical white socks. In his drawer, pulls one sock out at random and then another sock without replacing it. Determine that to the nearest 1/10 of a percent that he pulls out a pair of black socks. Okay, so the probability that he's going to get a black and a black. Okay, so he's going to get 2 black socks. So what's the probability that he's going to draw a black sock to start off with? Well, he has 8 out of a total number. Remember to do probabilities. You think about the favorable outcomes. I might as well just write that down on the top there. Divided by the total outcomes. So it's 14 socks. 8 out of 14 socks are going to be, this is the probability they're picking a black sock to start off with. And because they are dependent on each other, the next one is, what's the probability of drawing another black sock if I've drawn a black sock already? Okay, kind of put that in a weird spot. I'm just going to write that down here instead. What's the probability of drawing a black sock if I've already drawn a black sock? Okay, so there's one less black sock in there, and I have one less sock in total because I've taken a sock out already. So then I'm just going to multiply these two fractions together. And I'm going to get a decimal here. So let's do the nearest 1/10 of a percent. So I'm going to start off by writing my decimal out. And then I'm going to times it by 100, change it into percentage. So 1/10 of a percent is 1 decimal place, so this would be 30.8. I'm going to round that up. 30.8%. Which makes sense because there's more black socks than white socks there. Okay, so Logan's walking his dog. They walk by a river 5 days of the week, and they walk around the block 2 days of the week. Okay, when they walk by a river, they see other dogs 82% of the time, and when they walk around the block, they see other dogs 34% of the time. So let's draw a tree diagram because I've mentioned maybe we're going to figure out the probability that his dog will see another dog to the nearest 10th. Okay, so the first thing I want to do is what's the probability of him walking around a river or walking around the block? If I just pick a random day. Okay, so the river and the block. Okay, so the river is 5 days a week, so 5 out of 7 days, and the block is 2 out of 7 days. Okay, now when he's at the river, he sees dogs. Oh, sorry, rather than saying see dogs, I'll just say dogs. Okay, 82% of the time, I'm just going to write that as a decimal. Makes it a little bit easier to multiply. And I'll put not on the bottom here. It's just whatever's left over. 18%. Could do that mentally, I guess. Rocks on the block. You'll see dogs 34% of the time. It's 0.34. And then not, I'm going to write that as, oh, how can I do that? 66.66. Okay. Now, what I want here for, well, actually, I'm just going to multiply all these out. Might as well just do that. What's the probabilities of these happening? Okay. So 5 over 7 times 0.82. So this top one here, seeing a dog at the river, 0.58. 6, 7. I'll put down 4 decimal places here. Not seeing a dog. I'll put a 6 on that one. Around that. Seeing a dog around the block. So what I'm doing here is I'm just multiplying my probabilities out here. Not very likely in this situation. And then 2 over 7 times 0.66. Okay, the last one. Now, how I know I did something correct here is if I took all of these and added them together, I should get 1, right? I'm going to use my rounded numbers. The problem with using rounded numbers is that you may not get exactly 1 depending on how you rounded each of the numbers, but you should get something really close to being 1 here. Yeah, what I get is 1.001 because my rounding. So there's 100% certainty that one of those events are going to happen. Now the probability that you'll see another dog, if I pick a random here, would be this top one and this one added together. So I'm just going to add those two numbers together there. And I'm going to get, we put this to the nearest 100, so that's 2 decimal places here. I'm going to add them first. So 0.68 or 68% chance that he'll see some kind of dog today. It's just some random day. Okay, hopefully that helped out. So your test is going to be this week. Hopefully you're going to do sometime this week by Friday. It's the due date. It's going to be on the 2 assignments, assignment 1 and 2, assignments, total assignments 2 and 3, but the probability assignments 1 and 2. So all the probability together is 1. Okay, let's see you then. Bye.